Welcome to physics. We are starting today our texting and driving lab. This lab is going to take roughly the next 3 weeks as we wrap up this first quarter. So, this is really kind of our grand finale of what we've been learning. And so, just a little bit of an introduction. Um, Here's texting and driving. It is a real problem. One out of every four accidents in the United States is caused by text and driving. 21% of teen drivers are involved in a fatal accident were determined to be distracted by their cell phones. Statistics show teen drivers are 4 times more likely than adults to get into car crashes or near crashes when talking or texting on the cell phone. So, over the last 3 weeks of the first quarter, we will be collecting data, applying what we've learned about velocity and acceleration to analyze that data and make predictions based on various scenarios involving texting and driving. As you go in down this activity, okay, here's a little introductory video to represent the scenario. And this is a video made for Beaverton School District by a teacher in the Beaverton School District. So it's going to apply specifically to this lab. So I want you to take a couple minutes to watch this. Then while you're watching it, you should be able to answer what is our big question for this texting and driving lab. And just go ahead and put that in your own words. Next, I want you to think about what factors are going to be needed, like what are we going to need to know in order to calculate a texting and driving scenario. So with this, you can select all that apply if you think it applies to our situation. This first activity, I'm really trying to break down the lab into small activities. So the first activity is all about distraction time. So the first thing I wanted to do was help define for us what is that going to mean in this lab. So for our purposes, distraction time is the amount of time a person is distracted before they can react. And so to be more specific, in this scenario, it is the amount of time before the driver even sees that they need to hit the brakes. And so that might, maybe they are texting and driving, and then a stop sign is coming, and they look up, they see the stop sign. Okay, that was the period of distraction because now that they see the stop sign, it's going to turn into the reaction. So, how long does it take for them to react? So, right now, we're just focused on the distraction before they react. And our next activity is going to be about reaction time. So, as we begin our research and build our texting and driving scenario, we first need to learn about the average amount of time a driver might be distracted. So, to collect data on this, here's our activity. You are going to be asked to record the time it takes for you to pick up your phone, open it, read a text, reply to the text, and put your phone down. To show this, I gave a video here with a specific example. I have a link for a stopwatch here that I used in this example. And you need to open this spreadsheet. It's a template that I've made for you. You don't have to change a thing except for entering your data into the data table. So to show that, as I open this, it'll force you to make a copy. So this is now yours. You can change it. But again, everything is created for you, and all you have to do is enter the time it takes you to do that process. So again, I would be collecting data on when I open my phone, read a text, respond to the text, and put my phone down, and then I end the timer. So that would go here, and I apologize. This is loading. You're going to see a graph here. Perfect. As I enter the time, let's say that took me 30 seconds. You're going to see that it's going to update this graph, and you're going to see that it's going to update the average time. As you Here are just some practice numbers. Okay, so let's say these are your data. You're going to do this 10 times. You're going to collect your data so you can see this graph, and then you're going to get your average time here. You need this information so that you can help answer these questions. Okay, so once you've filled in that data table, I want you to take a picture of your graph. Just a reminder, that's going to be the Shift and Control plus Show Window key on the Chromebook. And so we've practiced that a few times, but you put that in here. Then, what was the longest time it took for you to read and reply to a text? You would look at your data. 30 seconds was my longest reply to a text in this example. Okay, so then I type in 30 seconds. What was the shortest time? I think it was 5 seconds. Yep, 5 seconds, which was probably not realistic. And then what was the average time? And then again, that's where I would take this average. Now, using your data, okay, so everyone's answer might be a little bit different here. I want you to go through these scenarios and we're going to practice solving for distance. So in these situations, you are going to be given a velocity, okay, in miles per hour, but I'd rather you use the meters per second. I think that'll be more meaningful to us as our time will be in seconds, okay? And I don't want you to convert a miles per hour to a miles per second, okay? That just is not going to be beneficial. So go ahead and use this velocity. And then it says, how far would you have traveled distracted if you answered your shortest time? So for me, that would have been 60 or 27 meters per second for 5 seconds was my shortest time. And then I can calculate the distance. And that's really your m times x, so your velocity times your time. So I would take 27 meters per second times 5, and that would tell me how many meters I traveled while driving distracted. I also want you to do this with the longest time. So if I was driving at 27 meters per second for 30 seconds was my longest time, okay, I could calculate how far I traveled without even looking at the road or distracted. Then, sorry, same scenario with the average time, okay? Then I want us to think about this, okay? There's a lot of real world examples and applications here. So, and this is going to be a short answer, but I'm requiring you to compare and contrast two scenarios and then use those calculations that you did in order to help you answer this question here. So, in April 9th, 2019, the city of Portland lowered the residential speed limits from 25 miles per hour to 20 miles per hour. Okay, so that's 11 meters per second down to 9 meters per second. Compare the two scenarios below and explain why the city might have decided to make that change. So I want you to read these two scenarios. You are driving down a residential street. This is one where like homes and apartments are called a residential street. And the speed limit is 25. That's most places. So here in Beaverton and Hillsboro, Tiger, Tualatin, all these towns around Portland, the speed limit in residential areas is 25. But the city of Portland just changed it to 20. So I want you to calculate. If you received a text message and you were distracted for 25 seconds, how far did the vehicle travel while distracted? Then I want you to do the same calculation. The speed limit is now 20 miles per hour or 9 meters per second. You were distracted for 25 seconds. How far did you travel while distracted? By looking at these two numbers, could you maybe think of an argument to why the city of Portland would have lowered the speed limit? Okay, and that just a couple sentences. I really want you to to refer to your calculations. Okay, so if you can say, well, I noticed that in the 20-mile-per-hour speed limit, it didn't quite go as far. Okay, and this means maybe there would be fewer accidents. Okay, so something that you could argue based on your data.